Welcome to the Mixtape with Scott, a podcast that provides an oral history of economics covering topics that span the last 50 years of the field. I focus on subjects that I like, though, things like Gary Becker's students or causal inference, to contemporary topics like economists in the tech industry. But it's also a platform I use to listen to the personal stories of real economists and scientists as they walk me through their lives from childhood to present, as well as walk me through the biographies of some of their own work. I'm your host, Scott Cunningham. This week, I had the immense pleasure of interviewing Stephen Barry, the David Swinson Professor of Economics at Yale and winner of the 1996 Frisch Medal for the best applied article in Econometrics. He's a very distinguished economist who publishes at the crossing of econometrics and a field called industrial organization, which is a theory of firms and markets. We dived into his life growing up in the Midwest, his love of science fiction as a kid, and the amazing faculty he studied with at the University of Wisconsin, like Charles Mansky, Gary Chamberlain, Art Goldberger, John Rust, and if you can believe it, many more than that. It was a real Hall of Fame group, and in what sounds like an amazing time to be a graduate student anywhere. He's the author also of a highly influential paper, popularly called BLP, which is short for Barry, Levinson, and Pecos. It's a 1995 article in Econometrics entitled Automobile Prices in Market Equilibrium. And it's had a massive effect in both industrial organization from a public policy point of view, as well as private policy point of view, given its widespread influence within industry. It's used for studying all kinds of questions that we sort of think of as defined by deep endogeneity related to market equilibrium, like demand elasticities. Thank you for tuning in. Don't forget to like, share, and subscribe to the podcast. Also, check out my Substack, Scott's Substack, where I semi-regularly post what I call explainers about econometrics. And now let me introduce you to Steve Barry. Thanks. Okay. Well, it is my pleasure to have on the podcast a man I admire a lot, Dr. Steve Barry. Steve, thanks so much for joining me today on the podcast.
I am very happy to be here.
Okay, before we get into your life, your whole life story, could you, for the sake of the listener, introduce yourself, tell us your name, your job title, and who your boss is?
Yeah, exactly. So I'm Steve Barry. I'm sitting here at Yale in New Haven, Connecticut. I'm in the Department of Economics, and I do all the professor stuff. And actually, recently I have a new different hat on, which is I'm heading a brand new policy center at Yale called the Tobin Center.
Oh, wow. The Tobin Center.
The Tobin Center. Yeah.
Oh, yeah, I heard of that guy. Okay,
yeah.
That's cool. I can't wait to hear about that. What? All right, I'm going to add that to here. That'll go into one of the questions. Okay, great. You're heading it? That's what you said?
Well, I'm the faculty director. There's a full-time staff, so I should be a little careful about how much of the heavy lifting is done by me, but I'm the faculty director.
Oh, that's cool. Okay. All right. We're gonna follow up about that. We'll put a little plug in for the new center. All right. So I wanted to start off with an icebreaker. If you could have a conversation with any historical figure, who would it be and why?
Oh, geez, man, I hate these icebreakers. I always feel like I'm gonna fail.
You're gonna have the wrong conversation with.
I'm gonna pick a dull guy, and I'm gonna say, "Oh my God, why did I pick that guy?" Okay, so they got to go across so many different fields, right? So okay, I'm gonna restrict myself to economics. It's just to make life simpler.
Okay.
Okay, and maybe it's because I was just thinking about it for our thing today, but I would love to go back the same way. I would love to have a podcast about the life and where did your ideas come from with PG Wright, who did
yeah. Oh, so you
I would like to have him on my, if I had a podcast in 1930, I want to have
you're going to talk to Philip Wright?
Yeah.
You're like, what's you're more proud of, appendix
how did
D or publishing Carl Sandburg's poems? That's great. Yeah, I want to talk about that. So he's somebody that makes a lot of sense. Okay. All right. So tell me where you grew up and what your childhood was like.
Yeah, so I grew up all over the place. My father was a med student when I was born, So I can truthfully say that I was born into the housing projects of Chicago, near the Northwestern Med School. Now, of course,
okay.
med school, so that's not, if you just mention the housing project stuff, it sounds like one thing.
Yeah, right.
And he was drafted. We moved around, kind of different places in the Midwest. He died. We ended up outside of Cleveland. And then I was an undergraduate at Northwestern. So I'm more or less a Midwesterner, but different places.
Oh, wow. Okay. You said he passed away when you were young?
When I was 11, yeah.
Oh gosh, that must have been hard.
Actually, it was. It's funny. At the time, I told myself it wasn't. And then later looking back, I thought, no, wait, you were wrong.
It was unexpected. It was sort of a, gosh, I'm so sorry. Yeah. Well, so as a kid, were there any subjects or hobbies that you were kind of passionate about?
I was a complete bookworm. I mean, I did play hockey for a while and stuff, but really I was just a classic old-fashioned bookworm. I don't think we had this word like nerd or something back there, so you were a bookworm.
Right.
You had heavy, thick glasses, and you had all your head buried in a book all the time.
Yeah.
My family would tease me. They'd say, at breakfast, you're reading the back of the cereal box.
What kind of books did you like to read? What would I have found on your bookshelf?
Yeah, so when I was younger, I really liked kind of classic old-fashioned science fiction. Was one of the things I liked. A bunch of people say they read Asimov's Foundation trilogy when they were young, and it's kind of social science fiction.
Right.
And I think Krugman has talked about this. I know Professor Chicago has talked about this, kind of looking back at it. Wow, how much did that have some effect? The idea of kind of like social sciencey, sort of quantitative people who could not control the world, but make some prediction about it.
Oh, wow. Wait, so how old were you when you read that?
I must have been like 12 or something. Yeah.
Oh, and you really got into it. So you were reading all the science fiction stuff.
Yeah, so I read a lot of science fiction, a lot of historical fiction, just pulling stuff off the shelves of the school library.
What'd your teachers think about you in high school, in like grade school and high school?
I think I was really nothing special until maybe a teacher found me in fourth grade. An African-American teacher. We were actually living in Southern Ohio, kind of in Appalachia. And she noticed I liked to read. And she sent me a bunch of books that had African-American characters, because there were no African-Americans in the school, and there were no African-American books on the shelves. And she said, well, you're a reader, and that's a great thing to be. And can you start reading these books? And somehow I think I kind of like, oh, I guess it's not just something I do. It's kind of interesting to other people too.
Right.
I think after that, I felt like I was a little more recognized as a good student.
So you were drawn to the fiction, but not the math. I guess you're going to tell me math at some point.
Yeah, no. I would have said I was much stronger in like writing and English and stuff. I was fine at math in high school. I mean, I did a sequence. I was fine.
Right.
In college, I took I did not have very good advising, it turns out. I took what I thought was a fair amount of math, but turned out not to be a lot of math, which I discovered once I hit graduate school. So it was not originally math for me. And indeed, I only got interested in calculus when I realized how connected it was to economics.
Oh, so what's your first experience with economics? Was that high school?
No, just, nothing in high school. Just enrolled, standard introductory micro class. And I was just thrilled. And suddenly it was like, oh, wait, I know what those derivatives were now. I know why someone would care.
Right.
Care that much. It's like, here's the time that an object goes through space, and here's the connection to the physics. And it never clicked particularly with me, actually.
Right. So wait, it was the math starts to come together in the econ classes as an undergrad?
Yeah, but in part it wasn't even presented. It suddenly occurred to me that there was a connection.
Right.
Like, oh wait, there's all this math behind the graphs. You could write it down. You could write down the equations. You could think about where they came from. You could, they're giving me slopes. Those are
right.
That's the first time I really made that connection, that there was like math behind this stuff, something that I was interested in,
Right.
something that involved human behavior,
Yeah.
as opposed to physical objects in space or something.
Right.
But
Wait, so what was it that was captivating you at the very, very beginning? Was it the social science part?
I think it was. I think it was. It was this idea that there's a set of analytic tools for looking at the world and thinking about, why do things work? How would you make things better?
Mm-hmm.
Um, yeah, I was just fascinated by it.
Yeah.
Maybe I do philosophy, but it's like this seemed better.
Mm-hmm. So like if you hadn't majored in econ, it's like that you might have ended up in the humanities.
Yeah, I might have done philosophy or something.
Right. Because you were you as a kid had this like rich life of the mind.
Yeah, exactly. But it was like, oh look, all this stuff can be come together in this other way that's more that's clear,
Yeah.
that provides a structure for your thinking.
Right.
So I thought that was really interesting.
Uh-huh. Okay. So did you have any role models or inspirations when you were in high
Yeah,
school?
okay. My father died. So I had a grandfather who in fact was a philosopher, which is probably one reason I was thinking about
Oh,
philosophy. He taught at a small liberal arts college in Ohio, Denison, which is outside of Columbus, Ohio.
yeah.
He wrote a philosophy textbook that was apparently a very well-selling philosophy textbook, which he joked with me when I started econ. He said, I wrote the best-selling philosophy textbook, and Samuelson wrote the best-selling econ textbook, and he's rich and I'm not, because you don't sell many philosophy textbooks. Also, top schools don't even use textbooks in philosophy. They just
Right.
assign Plato.
They assigned the books. Yeah, that's right.
Right, exactly. So being the text, it was geared more toward like not the top colleges. It was
Right.
geared toward places where you needed an
Yeah.
introduction.
Yeah. Yeah.
But I thought he was a very sort of moral person
Yeah.
who thought hard about like what should a person do,
Mm,
what should the world be like.
mm,
That's the way he wrote his textbook. It wasn't so much about the conundrums of epistemology or something. It was like philosophy is the study of who we are and how we came to be this way, and how we think and what should we do.
right. Yeah,
Uh,
sure. And you saw probably, I'm assuming, I mean, economics, you could see those questions even in econ, probably.
yes, right, yeah, more than say in my continental philosophy class. So
Right. So it wasn't just like econ wasn't just like a pure math thing.
no,
You sort of saw it as
yeah, yeah,
design.
right, exactly,
Yeah.
exactly. Like if you wanted to think about, what should we do,
Right.
right? This was a framework that was just
Right.
like, wow, that's amazing.
Right. Well, so which professors do you remember in college in the econ department as like sort of having a big outsized impact on you or their classes?
Yeah, so that okay. Again, I somehow I managed not to get great advisors. I had a good time in college. My advisors were not that great. I didn't take any of the people at that time who would have been like the top research professors. I took
Uh,
the classes that were popular with the undergraduates that said they were great.
yeah.
So there were things like urban economics and transportation economics, but again, they were super applied things like how do cities work, and
Right.
what are the issues and what are the problems, or
Mm,
transportation economics, or public economics, things where just there were just interesting policies to think about.
right.
So that's kind of what I did.
Yeah.
And again, that it confirmed my idea that this was useful stuff, right?
Right. Yeah. So when did you decide that you wanted to get a PhD in economics?
So I decided I didn't want to go straight to graduate school. I wasn't sure. Try the work world a little bit. At the time, I had a girlfriend in Columbus, Ohio, which was also not that far from where I had some family, and I moved there and I worked for a family-owned savings and loan. Actually, one of the first issuers of adjustable rate mortgages in the country, because they were an incredibly conservative family and would not issue 30-year fixed rate loans.
Oh, interesting.
Because that seemed crazy to them.
Oh,
And
wow.
I did that for a while. And I think confirming my view of who I was, they took me out of the general management training program and dumped me in their kind of analytic forecasting unit.
Mm.
where there were a couple early Apple computers that we ran spreadsheet models on. And that kind of confirmed who I was, that I was more of an analytical person than a business manager. And my joke, although this isn't really the truth, is that there was the day when I was going to have to learn to play golf or else apply to graduate school. So I applied to graduate school.
Yeah, right. Oh man, that's funny. Sure. Yeah, trade-offs.
Trade-offs.
Incentives. Yeah, exactly.
Yeah.
You're like, I learned this in school. So okay, so you get to Wisconsin. What year is that when you get to Wisconsin?
What year is that? 1982.
1982. So who's there in 1982? Wait, real quick. Did you take any econometrics classes when you were at Northwestern?
Yeah. Oh my God. Okay. No. Oh, Northwestern. Yes. Yes. Sorry. At Northwestern, yes. But again, maybe not the best advice. A slightly odd Bayesian undergraduate course where the guy kept telling us that he wasn't like the other classical econometricians, but I didn't know what that meant.
Yeah. Right. Yeah. Right.
He kept contrasting himself to this other thing that I had never
Right.
learned.
Right. Yeah, you're right.
So Northwestern, again, that's all I did. The econometrics faculty at Wisconsin while I was there was unbelievable. It's
Oh yeah.
hard to imagine. So I took first year econometrics from Art Goldberger.
Oh my gosh.
Who you probably have seen his classic textbook. And,
yeah.
He was just a great teacher. He had these great lectures. You learn the linear models so well and so deep. And just these great insights. He would do readings aloud of people who said their R squared was reassuringly high, and why they were reassured. He had his famous lecture on micronumerosity, which was actually just a satire on multicollinearity.
Oh.
There's actually a chap, he actually has a whole paper on micronumerosity and what one should do to fix the problem of micronumerosity.
Wow.
Trying to avoid that getting more data was the answer. For micronumerosity.
Did he teach your first year econometrics class?
First year econometrics, yeah.
So when you go in, you only have that experience with that Bayesian guy from college. What was it? So what happens during that class?
It was just, again, at first graduate school was very hard for me. I did not have the mathematical background. Presumably that's one reason I was at Wisconsin instead of Harvard or something. I just didn't have the math prereqs, and they would still let you in it.
What'd they need back then? What was it back then? What was sort of the standard line, the prereqs math that you needed back then?
Yeah, so the thing that was stated on many schools, but not always, was linear algebra.
Yeah.
Now people were starting to take real analysis, which I finally did the year after my first year of graduate school. But yeah, and there were a lot of people who had masters from the LSE.
Oh, right.
They'd taken graduate courses as part of their undergraduate training, and I thought they were all geniuses because they would have a constrained optimization problem and they would just whip off the answer. And I was like, at first I was like, how did you know to do that?
Right.
And then I figured out, well, that's just a really standard, almost algorithmic solution, and they learned it elsewhere.
Right. They learned it elsewhere.
But I thought that for a while, like, you guys are geniuses.
Yeah. Right.
Oh wait, you had this before.
So during Dr. Goldberger's class, I mean, you sort of begin to grow. Something changes.
Yeah. So again, I found out that I was okay at it, right? I mean, that I could do that, and I taught myself linear algebra more or less on the fly, and got good grades. Yeah, didn't think of myself. I mean, by the way, I still don't think of myself as an econometrician by any means.
Oh, really? You don't identify with that name?
No.
Oh,
no.
Interesting.
No.
Wow.
Yeah.
You're an IO.
I'm an IO guy. Yes.
Right.
Yes. Yale has become much more applied over the years. I had an offer at a top business school, maybe 20 years ago, and I said, "What would I teach?" And they said, "Well, econometrics, of course." And I said, "That's
you turned them down."
At Yale, I'm the data guy.
You're the data guy.
I'm the data guy. Yeah.
That's great.
We have John Andrews. I'm not teaching econometrics.
Yeah. IO is such a cool field because it's like it's one of the applied fields that's just has held on to the models so close.
Yeah, so we'll get back.
I mean, it's like so we learn all these models, and then, in a lot of applied work, it just comes down to really simple intuition. But in IO, it's just so deep. You just continue to work so closely with the theory. I bet that's been a lot of fun. I bet it's been a fun journey.
It's a fun journey. So now think like in Goldberger's class, one of the set pieces of the course would be simultaneous equations theory, of course.
Yeah.
This is the, an epitome for an economist of the linear model, systems of linear equations, models in linear form, thinking about exclusion restrictions and excluded variables that were derived from that linear system, right? That the instruments are there in the system because you've fully specified the equation. So, I mean, that influenced me a lot.
And y'all learned that in that first year?
Yep.
That first class?
Oh, yeah. That would be standard econometrics, because this is how you thought about endogeneity, for sure.
Right. You used instruments too, though, right? Within that,
of course, because the instruments come out of the simultaneous system, right? They're there. They're in the other equation determining, there's an equation for y2, the variable that shows up later, in some other place on the right-hand side of a y1 equation. And so you could see which variables are in the system that affect y2 but don't affect y1.
Right.
Set up a big matrix, and basically the exclusion restrictions and relevance are necessary to invert the matrix that you're going to need to get the answer.
Yeah.
Instruments are there, often called an instrument, but not always called an instrument in some sense. It's basically a set of exclusion restrictions, and it's the right patterns of excluded and included variables to learn about the coefficients that you want to learn about.
Yeah.
So that's the way I learned that. And then
you're learning econometrics really at the so closely wedded to market equilibrium.
Yeah, that's right. So the two examples we got were supply and demand, which I carried forward, systems of supply and demand, and one I did not carry forward so much, which were like, there's this classic thing that goes back to the Coles Commission of motivating the simultaneous equations of a Keynesian model.
Oh, really?
Yeah, like the consumption equation.
Oh, sure. Yeah, right.
Right. There's like this set of, and was that identified? And
wait, Goldberger's teaching you that, but that's just that's a little more antiquated in the
it felt antiquated even.
Yeah. And it's kind of macro a little bit.
Yeah, and also it's macro, so I didn't care, right? And then so Chuck Mansky taught our second year.
Oh, okay. So he would have been like a pretty new faculty member.
He was pretty young. So Chuck Mansky taught our second year. He taught us a lot of discrete choice modeling. He taught us method of moments early. He was very into teaching econometrics. I didn't quite realize it at the time, but realized it later, very much from the viewpoint of identification, that there's a model. How do you learn about it? What are the restrictions of the model? How do you learn about the model? So, if he were to teach OLS, he wouldn't say it's a least squares fit. He'd say, here's a model, there's an error term. We're going to assume that the X's have zero covariance with the error term. Solve that moment problem, you get the OLS coefficients. If you're going to teach instrumental variables, right, there's an error term, you think of its properties, what is it uncorrelated with? Those are your instruments. That's a moment condition, solve that. If you think about MLE, you might think of the first order conditions of MLE as a set of moment conditions.
Right.
And then you would build your knowledge of, the variance of the estimate and stuff up from that.
Does Mansky kind of have a big shadow on your ensuing work? I don't.
Yes,
he does. How come?
So I'm not sure he knew that either. Really, I think he thought of as being different of much of our career. But yes, a big shadow. Also, he taught us simulation estimators, maximum likelihood, discrete choice, McFadden style models.
Oh, right, yeah.
All of that had a big influence. But also, I think just this point of view that you think about an economic restriction, you derive an estimator from that. You think about the economic.
Yeah.
He's done that throughout his career in different ways. Sort of, Anyway, so he had a big influence.
Well, go ahead.
Yeah,
go ahead.
So at some point, there was 1 year when I was at Wisconsin, 1 year when they had obviously Goldberger and Mansky, but also Gary Chamberlain.
Oh, really?
Ariel Pecos. Jim Powell was technically there for a year, I think, maybe.
Wow.
Maybe was visiting. It was just an extraordinary econometrics
Did you
level.
know at the time this was kind of weird that you had all these people?
It seemed unbelievable, and it was unstable. People flew off to all kinds of places. Yes,
Mm,
it seemed amazing.
hmm,
But there was a lot of stuff going on.
mm,
It was just super inspiring.
yeah. Well, so
And
who taught you IO then?
right. So IO was very weird right then. It had been an empirical field, not very connected to theory, and
Oh,
game theory was coming in.
oh, right.
So the IO is becoming a game theory field. So IO is game theory. Labor was applied econometrics. And at Wisconsin, it was a fair number of models. Chris Flynn was there, other people were there. Chris Flynn was a Heckman student.
Mm,
So labor was very empirical, somewhat model based. IO is a pure theory field.
mm,
Coming out of it, there was an older empirical guy who was kind of, his approach was going out, and there were some young game theorists. So I learned game theory, and I learned some techniques from the more structural labor people.
mm.
John Rust was there teaching dynamic models.
Oh my gosh. Wow. I don't know
So
the full history of Wisconsin, apparently. I
yeah,
didn't.
I mean, this didn't last. I mean, 5 years after I graduated, Goldberger was still there.
Right. Wow. So you studied
Uh,
with Rust? You studied with John
I
Rust?
sat in on John's class. I mean, he was just a few years. I'm not even sure John's much older than me. I think he's maybe 2 years older than I am. But
Oh,
anyway, he was a whiz at MIT, and I sat in on his class toward the end.
wow.
And then Ariel Pickus joined briefly.
Hmm. What's the age gap between you and Dr. Piggis?
It's 9 years, I think, probably 9, 10 years, 10 years, 10 years. Probably.
Okay.
Yeah.
So what is your job market paper? Would you end up doing
My
that?
job market paper was on entry in the airline industry. Um,
Oh,
Actually won the Frisch Medal. Um,
it
uh,
wasn't what?
Won the Frisch Medal of the Econometrics Society.
Oh, okay.
But Ariel changed it a lot because I had a set of ideas. I was going to go on the market, had a set of ideas, and he came and said, you've made all these functional form restrictions, and you could really free them up if you use these simulation estimators that I'm working on. So I stayed another year and did that.
Did free it up?
Yep, freed it up. Got me a job at Yale. I don't think I would have gotten
Yeah.
coming out of Wisconsin. So yeah, it worked. Yeah.
Wow. Wow. What's that project about? Actually, now everything's running together for me. What was
Yeah,
that?
so I mean, looking back at it, that's a really good question what that paper was about. Because a little bit it was about, can you take a game theory model and estimate it? Which isn't a great
Right.
economic question for someone who was, got economics to solve a problem. But there was a big debate then about the role under deregulation of these airline hubs that were forming, and were they frustrating competition? So
Yeah.
it was about the formation of these hub networks.
Yeah. Yeah. Why? Well, so just for the sake of the listener
Yeah.
who hears, it's a question as to whether or not you could estimate something in a game theory model. Can you tell me what you mean by that? Why is that a
Yeah,
problem?
so here's I teach the freshman micro, and when we get to oligopoly and we talk about the theory of games, we say that the problem there is that in a game theory, which is a game theoretical model, is a metaphor for some strategic situation in the world. It's a model that's a metaphor for that.
Mm,
What I do depends on what you do. So I need to think about what you're going to do. But I know that you're thinking about what I'm going to do. Right. And
right.
then I think about what you think I'm going to think about what I'm going to do. So all the decisions are interrelated.
Yeah.
So there's this really deep kind of simultaneity where,
Yeah. Right. Right.
the model is defined like by a fixed point of reactions into reactions. Right.
Mm,
So sort of your first thought is everything is endogenous, or
right.
lots of things are endogenous. And the other thing is, I just looked at the standard, a number of us did at the time. Tim Bresnahan was already doing it. You look at the set of tools on the shelf that I'd learned from the labor economists. It's like, is this a probit? Is it a hazard model?
Mm-hmm.
It's like, what is it?
Right.
And these models didn't seem to map into any of those just kind of off the shelf tools.
Right.
So the question is, how could you think about data generated from a strategic situation where there's an equilibrium in play, and how would you think about estimating that?
Right.
Puzzle.
There's not a precedent. There's not like you couldn't even do what Goldberger was doing in the simultaneous equations and kind of like riff on it a little bit.
Well, I mean, it obviously influenced me for sure, but many of the hard problems were, well, entries discrete, right? So that doesn't sound very linear.
Right.
So part of it was there were natural nonlinearities. But yeah, in the end, it turns out to be a system of simultaneous equations. So there was something to that. And you have to think about what's shifting them and how you would model them.
Yeah.
I think this general issue, since for better and worse, I owe through my young decades in the profession on kind of a methodological quest, which was how were we going to deal with these issues?
The issues of endogeneity, the identification.
Endogeneity of the form that show up in game theoretic context. Right. That's real simultaneity, not just correlation with an unobservable, but variables within the system are causing other variables within the system, and there are multiple variables. So it's not like the one endogenous thing.
What did it feel like? I mean, when you won this, you get this incredibly prestigious award, this Frisch Medal. What was that like?
It was great. It was particularly good since the first time I came up for tenure, I didn't get it. And then I almost immediately won the Frisch Medal. So that felt good.
Yeah, they were like, we made a mistake.
Actually, my colleagues, I think, were always behind me. There might have been a university committee somewhere.
Right.
But so that felt good.
That's awesome.
And by then I was also working on BLP by that point.
Okay. All right. I can't wait to talk about this. So what year are we at? So before we get into the BLP, can you sort of set it up a little bit for the sake of those who are listening and don't have any background in econ, or just the context being supply and demand?
Supply and demand, right? This is
you could tell me a little bit about what is going on and why that's going to create any issues for, well, what is it you want to know when economists want to know stuff, and then just tell me anything you want to tell me about that before we talk about.
So for anyone who has had any economics at all, like just if you dropped out of econ after 6 weeks, the first thing you see is a supply and demand model. So there's demand coming from consumers, there's supply coming from firms, there's an equilibrium where the two curves cross. And we tell the undergraduates it's this tremendously powerful model where you can do all kinds of policy analyses. Put a carbon tax on gasoline, all that will shift the supply curve, it'll move against the demand curve. How much will price go up? Depends on the shape of the supply and demand curves, as well as the amount of the tax.
Right.
Another really cool thing about supply and demand is that in some cases, you can predict the effect of policies that you have never seen. So it's not just ex post policy evaluation, it's ex ante. So again, take that model we give to the undergraduates in week 3 or 4 or something. You put a tax on a good, there's never been a tax on that good.
Right.
Structure of supply and demand will tell you what the buyers will pay, what the sellers will pay, and how much will be traded. What's the social welfare consequence of that? I'll tell you all that. Right. So it's this amazing tool. But it has this feature of simultaneity that you can't say that prices are causing quantity or that quantities are causing prices. That's true within one curve, like within demand or within supply. There's a relationship between quantities and prices, but it's an equilibrium relationship between quantities and prices. And really, it's the system that throws out the price and the quantity. System of equations that creates the outcomes. And that's different than cases where you start with the question, what is the effect of X on Y?
That's different from like a kind of Rubin-y type
question. Because right. So think about it. It's not there in that model, there is no single effect of price on quantity. It's not really well defined. There's an effect in consumers' desire to consume, and there's a different effect in suppliers' willingness to supply.
Right.
So you look at the cloud of points of quantities and prices and things that you would see in the data. It's not true that price causes quantity or quantity causes price. The factors that shift supply and demand cause price and quantity.
Right.
Through the system. They pass through the system and they come out.
Right.
But we're interested in the components of the system, not just in the pass-through of a demand shifter to price or quantity, because it's the separate components of supply and demand that allow us to do this ex post policy evaluation. So this becomes this tool for the questions I studied as an undergraduate, right? To what's the effect of the carbon tax? How do you solve global warming? Those are, to an economist, those are kind of supply and demand questions. And to me, that's what makes IO distinct. It's some of the other applied micro fields. It's this focus on the equilibrium outcome. And, if it's interesting, probably something interesting like a policy change.
Right.
Where things are being determined simultaneously, not simple X causes Y.
Right.
You can write a demand curve using Rubin notation. You mentioned like the statistical framework. You can write a demand curve using that notation, obviously.
Right.
But it's a kind of different thing in that you're not going to get a policy question answered by just knowing the effect of a demand shifter on price or something like that.
Can you sort of contrast, so could you sort of do like a straw man kind of conversation where somebody is saying, I think of it as a price causes quantity, and sort of help me understand a little bit better about what's missing in that kind of reasoning that you said.
Yeah, sure. So sometimes, I've actually jokingly thought about this, that someone could come who was trained in a different tradition and say that I'm going to find the effect of price on quantity.
Right.
And maybe they come up with something they think causes price and somehow isn't present in that relationship, is excluded. So it's an instrument. One person might do it and find a positive relationship. Another person might do it, find a negative relationship.
Right.
Well, how can that be? Well, if you understand supply and demand, you understand, well, there are positive and negative forces at work. Right.
Yep.
You have to disentangle them.
Right. You're talking about in an equilibrium system, increases in price have effects on equilibrium outcomes because of supply and demand.
Because of supply and demand,
yeah,
right?
Because so they affect people differently.
Separately,
right?
You may say, gee, on average, prices and quantities barely seem to affect each other.
Right.
One goes up, one goes down. Sometimes they both go up together, right? But if you thought, if for an undergraduate, right, says, oh, look, there was an economic boom, demand went up, the price of oil went up. Another time, oh, look, the Saudis held back on oil. The price went up, demand went down.
Right.
That's because one time the demand shifted, the other time the supply shifted.
Right.
And if you don't separate those two effects, A, you can't even understand what's going on.
Right.
But B, you can't do this kind of policy evaluation.
So that paper, so when you said you had been working on it for a while, so tell me what's the very beginning germ of an idea where you're starting to think about the inadequacy of what's available at the moment.
Right. So I think that
McFadden's estimating demand with on the BART subway or BART line a long time ago.
Long time ago, right. So I had been thinking about that paper, in fact, and that work pretty hard. And what was confusing to me is there seemed to be no problem of price endogeneity. It never came up. And I was like, why is that? How can that be? It seems like it's demand, but how are the prices determined? And what I had realized is that there is no demand unobservable in the McFadden model. There's nothing like a demand shock at the level of the market. And
nobody had said that before? That wasn't like a widely...
I don't know of someone saying... I do not know of someone saying that before. I do not. And someone might have mentioned it by now, although you never know, because often a lot of
exactly
things come up later.
People have people have vivid memories when everybody knows something.
Exactly. Suddenly they find that
suddenly they're like, I thought of that.
And okay, McFadden was also very smart. So he had something in his discrete choice models, which were a choice specific constant. And that was being held fixed. So later on, I came to think, okay, the unobservables are in that constant somewhere. And so but if you were to move across markets, maybe that constant would shift. Maybe it would shift according to some things we see, some market level things, and maybe some market level things that we didn't see.
Right.
And then voila, you have a demand error. And then if prices shift in the second market, you worry that prices are correlated with that shift. Right? So I thought, it doesn't take that much of a change to get the demand error in there, but particularly when you ran across markets. So I'd been thinking about that. And actually, I have a paper in RAND 1994 that's way easier to read than the later work, if someone wants to read it. It's probably a much easier place to start on this kind of question. And the useful thing, by the way, should have said, why would you think about the discrete choice literature at all, is it lets you think about differentiated products. So I just mentioned the undergraduate model where there is a demand curve, but you look out in the world, and McFadden looked out at transportation, and it's like, well, the bus is different than walking, is different than subway, right? Is different than the car. We look at consumer goods and automobiles and everything, and many things are highly differentiated in geography and product characteristics and quality, perception and marketing. So for all the reasons we wanted to do supply and demand before, I wanted to do supply and demand in a differentiated product setting. And to a large degree, McFadden had, but without this price endogeneity issue. So I had been thinking about that. Jim Levinson came and gave a seminar at Yale.
How old are you at this point, Steve?
So it's probably 91, 92. So I'm like 32, I guess.
So you got tenure, right?
Well, was I tenured yet? No, not quite, almost.
But you're thinking about, is it that you're thinking about that McFadden?
Yep, I'm thinking about the McFadden stuff.
That's what's kind of the germ of it. You're not thinking about automobiles.
No, I'm not thinking about automobiles in particular. I've been thinking about airlines. But not automobiles. So and I had been thinking about maybe an airline model. Jim Levinson came, gave a really nice paper he had written with Rob Feenstra, a trade paper. There were lots of trade questions about automobiles at that time. The Japanese were going to take over the world. All the cars were Japanese. There was trade policy to keep the Japanese from taking over the domestic market. How should we think about all of that?
Yeah.
Well, okay. Different. Okay. Supply and demand, but differentiated products, and it's imperfect competition. So demand is different. Supply is different. Imperfect competition, which is like a game theory problem, and it's differentiated products.
Right.
And they modeled cars as being in a product space, size, fuel efficiency, number of doors, things like that. And they presented a paper that was very, very interesting, and also probably had some issues. So the three of us talked, Jim and Arlo and I, afterwards. And
had you and Dr. Packus kept up from grad school?
Yes. And why in particular? Because the year, a month or so after I accepted my junior offer at Yale, he accepted a senior offer.
Oh, he was there.
We were colleagues.
Oh,
we're teaching together at Yale. Right, exactly. We're together.
Yeah. Is he teaching an IO class? Is that what he was doing, or was he teaching an econometrics class?
No, I think prior to coming to Yale, he had been thought of as an applied econometrician, someone who studied productivity, Zvi Grilich's student, Chamberlain's. When he came to Yale, he started teaching IO with me.
Cool.
I don't know if we ever had an IO class, but we started teaching it together. And again, Yale was very strong in econometrics. We had Peter Phillips and Don Andrews and good young people, and it was people like us were not econometricians at Yale.
Right. Okay.
Which I was fine with, because I was interested in the world. I wanted to model the world anyway. So that was
right. You're Isaac Asimov. You're thinking about the world.
Yeah, I'm still right, exactly. I still want to model the world. Right. Exactly. Exactly. Yeah.
Okay, so you're 32 years old. You're thinking about this model. You have this they present this paper, And y'all
right. So Jim comes, presents this paper, and it has all these cool features, but it's not clear how it's all worked out. So Ariel and I talked to Jim, and we assure him that between us, we have all the tools to solve this problem. Ariel's been working on simulation estimators, which makes more complicated discrete choice models possible. All three of us had been thinking a little bit about the imperfect competition side and pricing. Jim was thinking about that. I'd been thinking about the simultaneity problem in this kind of model. And it was going to be really easy to just string all these things together into a framework that would let us get back to the trade policy question.
Right.
It wasn't quite as easy as we thought.
Did it feel super ambitious when y'all are talking to him? The three y'all are talking, you're like, this is gonna be
a little naive. It's like, of course we can just put these things together. It wasn't that easy. It wasn't easy at all. We had I was working on a desktop computer that was a Intel 386 chip with the extra compute or something.
Wait, what year is it? It's 91, 92?
92, 93. Yeah, exactly.
You had the 386? Is that what you said?
Yeah, 386.
Yeah. That's right.
Exactly.
I remember the 386.
Like do this on a computer like that.
Yeah.
We hadn't done it before. There were numerical issues with the simulation. Could we get it to work? We had to work out the supply side. We worked out an inversion argument on the supply side that helped us. I think it's true that at one point, Jim Levinson, when something new was proposed, started asking when the next solution was supposedly easy, he would say, do you mean easy or do you mean Pecos easy?
Yeah, right.
Really hard.
It's hard. It's like super hard.
That's pretty hard. I got a year's leave at the Bureau. I got an Olin fellowship where I could just go in and just sit at the computer all day long.
What were you doing on the computer? Tell me, like, what are you doing? You're coding?
Coding, yeah, trying to get this thing to work, trying to figure out how it works.
You already had the econometrics worked out, or what's going on?
Much of it, but no, we would run into other problems. We would have an idea and run into a problem and try to come up with a better idea and sort of iterate on that. So going back and forth between thinking about the problem, solutions, and then seeing if we could code them.
Was there a natural division of labor during that time that you guys were kind of?
Jim and I were coding. Ariel was not coding. He was a senior guy. Yeah. Ariel was often a little more sophisticated on the econometrics, was helping solve econometrics problems. Jim was coding, thinking about all those things. Also, he knew the trade issues and the automobile data better.
Oh, I see. What data? Where'd you get the data? Well, how big was the data set?
It was not very big, really, because we didn't have, and I thought about this a lot recently, but it was pure product level data. All we had were the characteristics and prices of cars and their sales.
It's like that. It's like that automobile data in Stata.
Yeah, no, it's very similar. Yeah, it's right. It's a lot like that. Right. It was very similar to that. Yeah. Like, just like the auto data set. Right.
Right.
And we had it for like 20 years.
Okay.
Looking back, it may not have been enough data, but it's what we had and it's what we were going to do.
Well, so you would do something, it wouldn't work. What did you guys know it would look like if it did work? Your cut. What would you have said? Hey, I think we
wanted the supply and demand system. We wanted all the elasticities of if you change the price of one car, what happens to the sales of similar, not just to it, but similar cars.
So like, how do you know that you don't have it though? How do you?
Okay. Well, at one point it's just things aren't working, or things are horribly non-robust, or something like that.
Right.
In the end, we got an answer that didn't seem crazy. I think at one point Tim Bresnahan teased us and said, "Well, these guys tried several things, and then they tried some more, and then they stopped when the things looked good to them."
Yeah.
Okay.
I have a life.
When we couldn't reject it as being insane, we were like, "Well, that's not bad, huh?" There was some little truth to that, I think, a little bit. But we wanted something that had enough detail that we felt like we could do a policy analysis that wasn't crazy, results that were plausible.
Yeah.
And no one had really done it before, so we were just trying to show you could do it too.
Yeah. Well, so what happened? So you get this paper, you write it up. It's a beautiful paper.
Enormous. It's hard to write. I don't think we know how to write it up very well. People say it's hard to read. I believe them. And I believe them.
You're lying.
But I will say, sitting at the bureau, I was like, there's just an elegance to the way this stuff, people may not see it right away, but there's an elegance to the way this stuff fits together, the different parts put together. And this could be a hit. It's like, I felt like this could be a nice paper. This could be a nice people pay attention to, just because the model just felt like they were just parts. And I've had some other friends that tease me. They said, nothing in that paper is new. Simulation estimators were known, discrete choice models are known, simultaneity is known, oligopoly pricing rules are known. I'm like, fine, we just put it together. I'm fine with that. We just assembled the thing. I have no trouble with that characterization.
Sure. Okay. That seems a little condescending a little bit.
Yeah, okay. Maybe
it makes it sound like it was easy.
It's
pockets easy. That paper was Dr. Pockets easy.
Yeah, it was Fake is Easy, right?
Fake is easy.
That was only Fake is Easy, right? Exactly. That's exactly right. And it came out and people were really interested. But again, we were in an era where the fact that we had, the sort of game theoretic oligopoly pricing, impressed people all by itself.
Mm-hmm.
Paper got ridiculous references in the early years. Like several of my early papers did, like, game theory is an interesting topic, and the models might even be estimated. See,
right.
Like, oh
might.
It's like a little cheap, but I'll take it.
Sure. Yeah, that's right. That's right. Yeah. Okay.
Now, what I would say, one thing that I think people don't realize enough is we then turned to the trade policy question, and we wrote a paper published in the AER in 1999. And in some sense, that 1999 paper is the paper we intended to write. Had the trade policy in it. It also had better instruments and some other improvements. I think our instruments in the first paper were a little sketchy. And I think we did a much better job in the 99 paper, actually.
Well, so when did you get it gets published? When did you first notice that it was a hit? I mean, it gets a top 5, but you've got a bunch of those. So how did you start to feel like, when did you notice it was becoming influential?
Yeah, at first, it was a popular paper to give. So that's a good sign, right? There's just like seminar circuit demand for it, right? And then a few years later, Yves Naveau, who was a student at Harvard, wrote a paper on breakfast cereal and mergers, and got a great job out of it. And a couple of our students said, "Wait, you didn't tell me we could just run BLP and get a great job."
Get a great job.
Just run BLP. But they were like, "Wait, is that like something you can do?"
Right.
So other people started picking it up and using it for different policy questions. I think the point is it was a tool.
Yeah.
It's a little frightening, by the way, when you create a tool or crank, because people will crank it and they'll crank it idea and they'll crank it. It's a little not such a great idea.
Yeah. Can you do it in Stata? That'll probably crank it even more if you can.
Yeah, exactly. Right. I think someone did try in Stata. I'm not sure, but
I asked ChatGPT. I'll ask ChatGPT to write the Stata code.
There you go. The other thing is, we insisted on this whole random coefficients thing in the simulation, which makes the demand much harder. If you do something like nested logit, there are closed forums, and you can run it in Stata easy.
What were you writing it in? MATLAB, or what do you use back then?
So there was a language called Gauss.
Oh yeah.
Which was basically based on early versions of MATLAB, but MATLAB hadn't been commercialized much at that point. So Gauss was a matrix programming language, very much like MATLAB.
And you were that was your bread and butter.
That's what economists used. That's what John.
Oh, they were using Gauss. Okay.
John Rust wrote the Harold Zerger paper in Gauss, and that was the most common probably language, because it had the advantage of MATLAB and being a matrix programming language, which is good when it comes time to invert variance matrices and things. And it was more commercially developed at that time. And then later on, MATLAB beat them.
Right. Well, so let me ask you this. Since that's like the paper that you're probably going to win another award for one day, what's your second favorite paper that you've ever written?
Oh, that's a good question. It's hard to choose among your children.
Okay.
But okay. We're talking about lots of successes. Let me tell you about a paper that was kind of a publishing failure that I really, really like.
Okay.
So I had wanted to do this on airlines, and I had a colleague, Pablo Spiller, who was at Illinois. He's at Berkeley now. He had a somewhat older student who was a very good programmer. And we did a version of this for airlines. And we didn't do random coefficients. We did a mixed logit where hoping to find that there was a type of consumer who looked like a tourist traveler, and a type of airline consumer who looked like a business traveler. And on the supply side, we didn't just do the imperfect competition, but we modeled airline hubs as shifting costs and demand both. And to run it, this graduate student who was not young, ran it on the giant University of Illinois supercomputers. They had this great supercomputer center there. And I really like that paper. And the graduate student left, and Pablo left Illinois, and we lost access to the supercomputers.
Oh.
And it was on a third round revision at the AER, and it never got sent back.
Oh, because you couldn't get.
Yeah. And I got caught up in some other things. And at some point I'm like, wait, we never did it.
You need to call somebody up at the Illinois right now and get it.
Well, and it got published in I had tenure and it got dumped in a volume somewhere. And, but I actually think that
send it back to Orly Ashenfelter. Say, I finally
got the revision for you, Orly. Right. Exactly. Yeah, that's exactly what the editor was. And anyway, that's a paper that, like, so not everything always falls. Not everything falls. All the pegs fall in the holes all the time.
Right. Yeah, totally.
But I like that paper a lot. I also like my work, which is much methodologically simpler, with Joel Waldfogel.
That was my next question. I want to talk about that.
Really like
that seems that you're talking about. It's mostly radios, right?
Those
stations.
Radio papers. Yes.
Yeah. Will you talk about that? I was really curious about that. Radios seem so antiquated, but it was like the 90s. So I'm just curious, what were you guys working on?
Yeah. So the idea is that, so there's pricing aspects of oligopoly, but there are also product variety and entry aspects of oligopoly. And it's interesting because an oligopoly, oligopolists have slightly weird incentives. So you want to enter to provide a new good that people might like. But one of the things you can do is enter and offer a pretty similar good. And some people probably buy it anyway. And you'll basically just take business from an existing rival. As long as markups are positive, you make money, maybe you cover your fixed cost. So there are serious issues about this in generic drugs and different, or new drugs that are just Me Too drugs that are just like other drugs. But there was an old literature claiming this was a big deal in radio. That, there are old papers from the 50s complaining that, oh my God, there are 7 stations playing rock and roll, right? Even though there's some market for classical music. It's better to split the rock and roll market than it is to, serve the small classical market, even though you might think from a social welfare perspective, you'd like to have more variety.
Right.
So this is an aspect of oligopoly and imperfect competition. And radio was this classic point. We did think, okay, is radio, even then, you thought, is radio a big deal? It turned out that people spent about 15, at that time, people spent maybe 15% of their day listening to the radio in the car at work while they were making dinner. So it wasn't a huge
15 minutes. 15?
15% of their waking
15%.
Because people listen on their commute. Yeah. Just think about, why do you listen to Spotify now? People listen to the radio then.
Yeah. Right.
All the time you have your earphones in while you're working or driving.
Yeah, you can't call in. You can't call in on Spotify and
I know, exactly. Right. There's no shock jock in the morning to wake you up.
That's right.
So anyway, so that was a paper about business stealing. And there had been a classic theory paper by Mike Winston and Greg Menke on this idea that an oligopoly entrant might be motivated by taking business away from rivals more than just by providing a service or driving the price down.
Oh, that's interesting.
And we want to measure that. Like, is that just a big deal? Is the business stealing thing just like a big deal? And it's a pretty simple setup. Again, it's an equilibrium where there's a number of radio stations, and to what degree do they provide extra variety, and to what degree are they just very similar in stealing listeners from other stations? And the source of exogenous variation was that cities of different size can support a different number of radio stations because there's a fixed cost of entry.
Right.
So cities have a ton of stations, small cities have many fewer stations. And the basic idea was you're adding many more stations as you move from, Dubuque to New York. How much more listening do you get?
Right.
Like, do people variety and listen a lot more? Or is it just like you've got kind of a fixed number of listeners and we're just divvying this market up? So it's kind of just like
if it is distributing across the preferences of the consumer, then it is sort of, it is optimal. But if they're doing one of these,
like more listening, like more people
listen
more because they're getting their preferences.
But if you're doing one of these hoteling models, then it's just like we're all listening to the same
the exact same
music.
Thing. Right. We all so that was the measurement idea, that we're going to use this kind of natural experiment of population size to trace out kind of the listening share and then put that back to a model where you could interpret that in this variety way you just interpreted.
Yeah. So what do you find?
There is a variety effect of the new stations, but there's a ton of business stealing. If you looked just at and by the way, there was the revenue in the industry is coming from advertisers. So there was an advertiser demand function in there too. And it is true that new entry drove down the price of ads a little bit. So there was some benefit to advertisers there. It turned out that if you looked from just the viewpoint of the true market participants, who are the radio stations and the advertisers, there were way too many radio stations. You could just cut a ton of radio stations back, save a lot of fixed costs. Price would go up a little bit, but you'd save so much money, it would improve social welfare. Now, on the other hand, radio is interesting because it turns out that all of us listening in those days were not the market participants. We were unpriced inputs into the sale of ads. Yeah, we were just like the internet, right? If it's free, you're the product.
Right.
So so there might have been a coincidence there that there were way too many stations relative to the market participants. On the other hand, there was this externality to all of us unpriced inputs. And plausibly, those might have balanced out not too bad. So probably not a social disaster, but not because of some fundamental market force, but just because by happenstance, there was an unpriced externality that we were.
Well, so what do you think now that you've studied so much music? I mean, you've watched it go from radio into streaming platforms. I mean, what's new and what's just the same old stuff? And what do you think the big questions are?
Yeah, so Joel kept on this more than I did, actually. So I followed his work, and he's been really interested in these questions, like how much value do you put on the tail of the little songs and the little bands that you never would have heard on the radio, right?
Right.
That, the top station was only going to play this limited amount of stuff. So he's actually done fun stuff, trying to look at, how much do people value that tail. I think he finds it's pretty good for people, right? That this new world where you can find music is very valuable to listeners. Actually, that in the aggregate, that creates a lot of value.
Right.
I think the other interesting thing in music, though, is when I was a kid, you toured to support your album sales.
Yeah.
Now you put out music to support your concert prices. Right.
Yeah. Right. That's where the money is.
So that sort of changed.
They figured out price discrimination and
right. So rather than have a packed concert and then all the kids went out and bought your album, you made money.
Yeah.
Now Spotify's not paying you much for those listens.
Yeah.
That creates fans, and then you have a concert at a tremendously high price.
Right? Man, my daughters were saying, "Hey, can we have some money to go to Taylor Swift?" I was like, "Sure." And then I was like, "Is there an extra zero on this? What's going on?"
Exactly. There's something wrong here.
Way, as a kid, this doesn't seem. It's like the worst seat was not. I was like, "No, you can't. You can go watch."
Actually, literally
on Netflix.
Literally, we can't pay for that. No.
You get a job. Go get a job. You can go work for a summer and go get one ticket.
So that's fun stuff. But the fun thing is now in IO, I think we're in a different space. We spent a long time on methods. I would tease my macro colleagues that, they only had two parameters and no price endogeneity. And they would say, yeah, but you write papers on yogurt. Okay, touche. I think now we're seeing, and particularly among a younger generation of people who are really taking the tools that we developed and really digging into just tons of interesting questions and
Yeah.
equilibrium questions and healthcare and urban economics and education and environmental questions.
Yeah.
And there are all these kind of supply and demand questions.
Right.
You know, what does the deregulated market for elementary schools look like in Chile?
Right.
Where you get entry, just like I said, and you get business dealing, just like I said.
Yeah.
And you get pricing power, and the products are differentiated, and all the stuff we did for auto shows up, but it's education for poor kids in Chile.
Yeah. You know, it's funny.
And that's really cool.
It's funny, like your work just kind of reminds me of how and this isn't saying anything about a statistician. I'm just saying a statistician wouldn't have found what you're doing because it really had to come from thinking about supply and demand and models and behavioral models, and not really, it's not really statistics that's driving it. You know, it's this understanding of the world of like it's theory, not like statistical theory. It's like behavioral market theory. They would not find it.
Right. I think that's right. You need that. You need those models to help guide the work. Now, of course, then, as I said early on, once it gets a little bit complicated, then you need some statistics to figure out.
Yeah, exactly.
You know, right. I mean, is this identified? Is this, you know, what do I do with the standard, you know, with the standard error estimate of my parameter or whatever? And you need a lot of statistics in the end.
But, you need all this.
But the reason I don't think I'm an econometrician is I feel like I'm a pure user of that theory. I'm grateful for it. Same way I'm not a game theorist, right? I'm a user, right? I pull that stuff out from other people as needed. And I'm super grateful that it's there.
Right.
Because then you can just put all this stuff together.
Right. Well, this is the last question because it's top of the hour. So, you know, when you think about where the field of IO is now and where you just sort of see it going, what excites you the most about, you know, where you see this going right now?
I think it's this expansion out into more and more policy relevant areas, by the way, which is why I'm interested in this Tobin Center stuff. People say,
let's talk about that. Right.
People say they're surprised I do that. But my answer is I spent all this time building tools. If they can't help us figure out the world, I'm in trouble.
Right. So wait, what is this Tobin Center?
It's time to use them. It's time to use them.
Is the Tobin Center is a brand new policy center?
It's a brand new policy center at Yale, just set up, where we've been around for about 3 years. We've been able to hire some great staff. We're really trying to be sincere about taking economics, you know, often database, sometimes model-based, sometimes not, out into the policy world. And I have a colleague who said it's so sad. My young colleague writes a great paper. It has great policy implications. It goes in a great journal. And as far as the rest of the world is concerned, it might as well be dumped in a lake.
Right.
It never affects anything. So how can we take really good quality research and in a sincere way figure out how to get it out in a way that would actually help people?
So you're working on, you have faculty that are there, and it's not a public policy school. It's not like you get a PhD.
It's not a school. It basically involves the research agendas of economists across Yale and the econ department, into the School of the Environment, the business school and the law school and the School of Public Health, right? And it has to come up from the faculty because someone's got to do the research. And then the question is, how do you help support that through infrastructure, data infrastructure, help people get data on campus, help them secure their data, help them do the research. Then when it's interesting and solid and, you know, more than one person agrees it's good, take it out to the world. And so that's a new adventure. That's a new adventure for me, a very new adventure for me.
Oh, that's cool. Oh, well, good luck with that. That sounds fantastic. That sounds fantastic. Well, thanks for being on the show, and this was so much fun.
Great.
You know, I think you're really inspiring for those of us that also were bookworms and weren't good in math. And so
exactly, come on. Right.
if Steve can do it, the biggest bookworm ever, then the rest of us have hope.
Exactly.
Well, it's really an honor. And I hope we get to run into each other in real life then soon.
Yes, thanks a lot.
Okay.
It's a nice blend. I really appreciate your blend. It's fantastic.
Okay. Bye-bye.
Gonna see us through. Honey,